Right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present our outcome for experiment 2, which is input and output programming using assembly language. First and foremost, we need to address the objective of this experiment, which is upon completion of this laboratory session, the student will be able to program STM32 F446RE microcontroller using assembly language. So moving on to our first question. In this part, which is part 1, we are required to set a connection of LEDs in the breadboard as shown in figure 2, which is here. Then we need to write a program using microcontroller assembly language that will turn on LED D1, D2, and D3, and then turn off those LEDs. Before we are able to do that, we first need to consider the conditions for these LEDs.
Here you can see we have declared the clock at RCC AHB1E and R. And then we have GPIOB model, which are the BIC and ORR. GPIOB model is used to declare which pin that we will be using in this experiment. So as in the question, we will be using PB4, PB5, PB8, and PB9. So for the BIC, we will be using 1 at the port that we will be using. So we will put 1 at port 4, 5, 8, and 9. Whereas the other port that will not be used, just put 00. So the address that will be used are 0x0000, 0f00. For the ORR, the port that we will be using put as 01, which are port 4, 5, 8, and 9. Whereas the other port that we will not be used are put as 00. So the value that will be used for ORR are 0x0000, 0500. Next, we have the GPIOB ODR. This is where we will be deciding the condition for the experiment. So the first condition that we want is for the LED at PB4, PB5, PB8 to be turned on. So as the circuit are active low, we will be using 0 at port 4, 5, and 8. As the port 9 will be turned off. And the other port that will not be used put as 1, and the value that we will be used 0x0000 FECF. In order to make it blink, we have to turn off the LED after it is turned on. So as the circuit is logic low, we will using 1 at the port to turn off the LED. So port 4, 5, 8, and 9 will be put 1, whereas the other port that are not used and not declared will be also be put 1. So the value that will be used are 0x0000 FFFF.
So for the simulation for this lab, we use Kill. So firstly, we use RCC AHB1 ENER EQU 0x40023830. Is the address for it. So next we use GPIOB model EQU 0x40020400 for this address, and lastly we use GPIOB ODR EQU 4x40020414 for this address. So all these address are constant. So let's move on to the next move on. So first of all, we need to set for RCC AHB1 ENR. So this is the coding for the RCC. So I want to explain that why we use the hashtag 2 because we use port B for this simulation. So next, we set for GPIOB. So this is the coding for GPIOB model. So to turn on the LED, so we use this coding to turn on the coding for the simulation here. So for the GPIOB ODR. So to turn off the LED, so we use GPIOB ODR. So this is the coding. So after we simulate or the coding, we can get the result as question number 1.
Alright, so this is the result for part 1 where LED 1, 2 and 3 will blink simultaneously but LED 4 will stay turned off. Next, after we have done the first part of this question, we have to modify the program so that the LED will turn on one by one, starting from LED 1 until LED 4. So instead of 1, 2, 3, we need to light them up until 4 in order. So for this matter, we have to check for the required condition.
So for the first condition, we will be turning on LED at PB4. And we will turn off all the other LED at PB5, PB8 and PB9. In order to do this, we will be putting 0 at port 4 as the circuit is in active low. And the other ports we will use 1 to turn off the other LED and other ports. So as the result, we will obtain the value 0x0000 FFEF. For the next condition, where we will be turning on PB5 and we will turn off the LED at PB4, PB8 and PB9. We will be putting 0 at port 5 and 1 at the other ports that we will not be used. And we will get a value of 0x0000 FFDF. Next, we will turn on LED at PB8 and we will turn off the other LED and other ports. So we will be putting 0 at port 8 and 1 at other ports that will not be used. And we will get 0x0000 FEFF. And the last one, we will turn on LED4 at PB9 and we will turn off the other LED at PB4, PB5 and PB8. So we will be putting 0 at port 9 and 1 at the other ports. And we will be getting a value of 0x0000 FDFF.
For this simulation, it's the same before this. As we can see that most of it are the same, but the difference is from the output. So to turn on the LED for PB4, so we need to load the R5 with 0x000 FFEF first. So next we need to store the value of R5 in GPIOB ODR so that the LED for PB4 will turn on. So next, we load the R5 with 0x000 0FDF to turn on the LED for PB5 here. So next, we need to store the R5 in GPIOB ODR also. So next, we need to load the R5 with 0x0000 FEFF to turn on the LED on PB8. So next we need to store the R5 in GPI, OB, ODR. So next, last but not least, we need to load the R5 with 0x0000FDFF to turn on the LED on PB9. After that, we need to store the R5 in GPIO-B ODR. So that is the after we simulate the coding, so that's we get the result for this simulation.
Alright, so this is the result for part 1. After we modified the code so that LED4 will blink as well. So it will blink from LED 1, 2, 3 and then 4. Alright, now we move on to part 2, which involve an input for the output we have done in part 1. So in this part we are required to use we use two buttons, S1 and S2, to control the output for D1, D2, D3 and D4. So first we need to construct the connection of push buttons and LED on the breadboard as shown in this figure. Next, we need to write a program using the microcontroller assembly language that operate as follow. So the first condition is when the button S1 is being pressed, LED D1, D2 and D3 will blink on and off. But then when the button S2 is pressed, LED 1 will turn on one by one until LED 4. However, when there is no button being pushed, all LED must be turned off. So in order to accomplish this question or this part, we need to first look again into the condition before we move on to the simulation part.
For part 2, we will be using GPIO-A for the input and GPIO-B for the output. So we will be using port A and port B. So it will be 3. Then we have GPIO-B model. For the output part, it is the same as the output in part 1. So we will be using the same BIC and ORR. Next is the GPIO-A model, which will be used as the input. We will use PA1 and PA4 in this part. So we will using one at port 1 and port 4. And the value obtained is 0x0000030C for the GPIO-A model BIC. Next, for the GPIO-A IDR, which is the input, we will be using two switch. So for the first condition, where switch 1 will be used at PA1 and switch 2 is not used at PA4, we will be putting 0 at port 1 and 1 at port 4. And the other ports that will be not used will be put 0. And the value obtained are 0x00000010. And for the condition 2, where we will use switch 2 instead of switch 1, we will putting 0 at port 4 and 1 at port 1 and 0 at other ports. So the value obtained will be 0x00000002. Then for the masking, we will be putting 1 at both port 1 and port 4 and 0 at other ports that will not be used, and we will obtain 0x00000012. Next, we have the GPIOB ODR, which is the output part. For the first condition, where we want the all where we want LED 1, 2, and 3 at port 4, 5, and 8 to be turned on, we will use 0 at port 4, 5, and 8 because the circuit is in active low. So we will use 1 at the other port that will not be used. And the value we'll get is 0x0000 FECF. And in order to make it blink, we will use 1 at, at port 4, 5, 8, and 9 to turn off the LED. And the other port will also be put as 1. And as a result, we will get 0x0000 FFFF. And for the last condition, where we want the LED to be turned on one by one, the condition are the same as the condition in part 1. So we will use the same value when we want to turn on LED 1, which is on port 4, and the other port is turned off. We will use 0x0000 FFEF. When we want to turn on LED 2 at port 5 and turn off other LED at port 4, 8, and 9, we will use 0x0000 FFDF. Then we want to turn on LED 3 at port 8 and LED at port 4, 5, and 9 will be turned off. We will get 0x0000 FEFF. And the last one will turn on LED 4 at PB9 and LED at PB4, 5, and 8 will be turned off. And we will get 0x0000 FDFF.
For this simulation, we use RCC HB1ENR EQU 0x400 23830. Next, we use GPIOB model EQU 0x400 20400. So for port B, so next GPIOA model EQ 4x0 0x400 2000. For port A, next we use GPIOA IDR EQU 0x400 20010. For for port A for in input. So next we use GPIOB ODR EQU 0x400 20414. Port B for output. So this is all in constant. So next we need to set the RCC AHB1ER. Here, this is the coding for RCC. So next, we need to set the GPIOB model. So this is the coding for GPIOB model. So this is the PIC and OR. So next, we need to set the GPIOA also. So we need to load the R6 with 0x000012 for masking. So after that, we need to use the CMP command to compare the R3 with 0x000010 to set the condition 1. So next, we use the CMP command also to compare the R3 with 0x000002 in to set the condition for number 2. We need to load the R5 with 0x FFFFFF to reset the simulation. So for the condition 1, first we need to load the R5 with 0x0000 FECF to turn on the LED D1, D2, and D3. So after that, we need to store the R5 into the memory of R4. That's it, GPIOB or DR. So next, we need to load the R5 with 0x0000FFF to turn on to turn off the LED for D1, D2, and D3, and then store the R5 into the memory of R4, and that's it for the GPIOB or DR. So for the condition number 2, first we need to load the R5 with 0x000FFEF to turn on the LED at port PB4. So after that, we need to store the R5 into the memory of R4, and that's it, the GPIOB. So next, we need to load the R5 with 0x000FFDF to turn on the PB5, and that's it, D2. After that, we need to store the R5 into the memory of R4, and that's it for GPIOB or DR. Next, we need to load the R5 with 0x000FEFF to turn on the LED in PB8. After that, we need to store the R5 into the memory of R4, and that's it, or GPIOB or DR. Last but not least, we need to load the R5 with 0x000FDFF to turn on the LED D4 in PB9. After that, we store the R5 into the memory of R4, and that's it for the GPIOB or DR. So after we simulate the coding, we can get the result in the simulation.
Alright, so this is the result for part 2 when switch 1 is pushed. As you can see here, the LED 1, 2 and 3 will flash simultaneously, but LED 4 will not light up. Alright, so this is the result for part 2 when switch 2 is pressed. So as you can see, the LED starts blinking from LED 1, 2, 3 and then 4. But then you can see here that briefly after all the buttons are not pressed, none of the LED lights up.